mind. Anyway. All right. Where we are? Okay. So we are going to buffer solution with the addition of small amount of strong acid and strong base. Not much. We will be only doing 2 big questions and only, I think, 6 questions. All right. If you can calculate the 6 questions, we are done for tonight. So as a reminder, buffer solution, we have 2 types. We have our acidic buffer and also our basic buffer according to their recipe. Tengok apa yang duduk dalam beaker lah, right? So your acidic buffer over here, obviously the presence of your weak acid and also the conjugate base. And vice versa, if that is your acidic buffer, your basic buffer will be the weak base plus the conjugate acid. And the most important thing, 2 important thing of tonight is the formula. Whenever we are saying that it's an acidic buffer, can I have the formula of acidic buffer, please?
pH equals to pKa plus log conjugate concentration conjugate base over concentration with acid.
Thank you. Concentration of my conjugate base over the concentration of my weak acid. Why I ask for the formula straight away? I hope you realize that if you have watched the video, sebab saya takkan bincang soalan yang sama 100% dalam video ya. Okay, saya rasa ada satu je kot soalan yang sama dengan video, yang lain tu semua tak sama. Okay. So if you have watched the video, that is the most basic calculation of a buffer solution with addition. And I hope you realize that the formula that we use is not depends on what is added. Do you realize that? Okay. Whatever addition that you put in, the formula that you use is still based on the type of buffer. I hope you can imagine that my hand is actually moving right now. I look stupid, man. God's sake. Oh my God. It's fine. That's how frustrated I am over the weekend. To be honest, starting Friday night. Basic buffer. So, formula for basic buffer yang masuk lambat. Siapa yang masuk lambat tadi? Anas?
POH.
Anas?
Hello. POH equals to PKB plus log dalam in bracket concentration of conjugate acid per concentration of weak base.
Thank you. Alright. So that is the formula. Again, formula ni adalah benda yang kita akan banyak guna. Okay, sebelum saya masuk soalan, the next thing that I want to talk about is the addition. So, yang ni adalah lebih kurang sama dengan video first yang kita bincang hari tu. Okay, the very first video of my buffer solution, if you watch it, then you should know. Buffer solution, the function of buffer solution is to maintain the pH. Everyone agree? Okay, so kita tahu dia nak maintain pH, and our job tonight is to show that the pH is maintained. Then since we know that we are talking about maintaining the pH where the changes is going to be extremely small, betul? Since the changes is extremely small, before we go into calculation, first thing first, do not round off your answer. Semua jawapan kamu kena minimum 4 titik perpuluhan. Then only you can see the small changes, okay? And then going into the acidic buffer, where in the beaker, you have the presence of your weak acid and conjugate base. So sekarang kalau Miss Wong tambah a small amount of acid, strong acid, okay? So if I'm adding a small amount of strong acid, next question. Haikal, the strong acid will be neutralized by who?
Conjugate base.
Thank you. Logic sayang. Strong acid akan sentiasa neutralized by the conjugate base. Okay? Dia mesti sentiasa neutralized by the base. Logic dia sayang. Acid ambil base, base ambil acid. The end of the story. Okay? Dan sekarang, if you look at it, a bit of extra thing over here. Do you realize that my arrow is single-headed? Alright, siapa yang tak, realize now. Next question. Why single-headed? Open question.
Completely.
Neutralize completely.
Neutralize completely. Thank you,
Strong
Aizal.
acid.
Thank you, Nawesh. Thank you, Haikal. Because the arrow represent that the reaction neutralized completely. Thank you, Nawesh, for your webcam. Finally, I see someone, even though you're not seeing me. Now you know when you're on the webcam, when I on the webcam and you didn't. Balas dendam. Okay, and over here, we will be playing around with only the species in the buffer. Kalau conjugate base kita dah guna untuk neutralize the acid, what will be formed as the product? Haikal, habiskan? Haikal, habiskan? Haikal dah jawab satu soalan, betul dah belah. Diana?
Weak acid.
Weak acid. Diana, are you back to college?
Yes.
Do I have the chance to see you before the exam?
Yes.
Lovely. Orang pertama yang saya nak jumpa, sangat-sangat orang lain pun saya nak jumpa juga, bukan saya tak nak jumpa. Tapi Diana ni dia special case lah, nak jumpa sangat. Macam tu lah. Okay, so this is what happened. And this is the basic thing that you need to know. Dan senang je sayang, kita akan bermain dengan orang yang kita ada dalam beaker. Kalau saya tambah asid, kita akan ambil base. Dan orang yang kita hasilkan masih adalah orang yang duduk dalam beaker. So kita ada dua orang. Betul? Dalam beaker kita ada dua orang. So kalau saya guna A, saya akan hasilkan B. Kalau saya guna B, saya akan hasilkan A. Contoh, if I'm adding in a strong base, OH minus. So the OH minus is a base. Then the one that will neutralize the base will be my weak acid. So if weak acid is used to neutralize the base, then I will produce my conjugate base. Agree? Okay, very simple. Easy. Last thing before we move on to question. Okay, untuk basic buffer pun samalah. Basic buffer exactly the same. Oh, kena ajar lah. Nanti tak ajar cakap Miss Wong tak ajar pula. The same thing if I'm adding in strong H plus over here, the acid will then be neutralized. It's an acid. So it will then be neutralized by the weak base, forming the conjugate acid. Okay, the same thing. Over here pula, kita akan tambah, add in the OH minus. Kalau kita tambah strong base, obviously the one that will neutralize the base must be the acid. So it's our conjugate acid in this case, hasilkan balik the weak base. Alright? So sama je lah. The last thing before we move on to question. Guys, what would happen to the pH changes? Or what would be the changes that you predict over here? Okay? Dan of course kena panggil nama sebab ramai sangat. Kalau tak, Nawash yang akan jawab, orang yang sama je akan jawab. Next, I want... Saya lama tak dengar suara kamu. Fazlina? Fad?
Yes, Miss.
Yes. What would be the pH that you expect when a strong acid is added?
When a strong acid is added, less than 7.
Less than 7. The acidic buffer, the pH is less than 7, yes. But what happens when in the acidic buffer you have an addition of strong acid?
Macam mana Miss, saya tak dengar?
Okay. What happened to the pH of your acidic buffer when you have a strong acid is added?
Not changes?
No changes. Anybody want to say anything?
Drop
Slightly.
slightly.
Drop slightly.
Thank you, Shikin. Thank you, Harisha. Thank you semua yang buka mic. pH drop slightly. Betul? Vice versa dengan base, kalau kita tambah adalah base, pH will increase slightly. Fazlina, tonight lecture will be quite heavy. Good luck if you didn't prepare. Okay. So, a kind reminder over here, pH, kalau kita tambah acid, pH kita akan cuba maintain the pH. Sebab tu saya kata changes dia adalah kecil. Walaupun dia changes kecil.
Boleh.
Sorry, Intan. Intan, your mic is on. Alright, someone text your friend, please. When you have a strong acid is added, the pH will still change. But the changes is very small and the changes represent the pH dropping. Sayang, bila kamu yang tambah tu adalah acid, pH jatuh lah. Yang kamu tambah tu base, pH naik lah. Tu je. Okay? Kenapa saya ajar teori? Sebab kamu nak jawab objektif, sayang. Bila kamu nak jawab objektif, jawapan A, B, C, D yang pilihan banyak-banyak tu, kamu boleh buang dah jawapan yang tak logik tu. Sebab tu saya ajar cara ni. Alright? Kalau soalan tu baik, kalau tahun ni dia baik hati lah sebab bagi objektif kan. Oh, tahun ni tahunnya sangat baik hati. Very first question, very simple question, something that we have discussed last week, a lot of it. And I want the pH of the solution above. Yang ni saya tak tunjuk dah. Yang ni adalah something we've been doing for the past 2 hours last week, I think. Please. Semua orang, please. Make sure you know the first step. Oh, something is missing, right? Okay. It's a 5. Sorry for the bad writing. Ya, anyone yang tak ada jawapan, saya nak pH of this buffer. Bear that in mind, we are talking about buffer, so saya nak jawapan dalam 4 titik perpuluhan. Bear that in mind. Just make sure you're on the right track. Ani, the pH that you're expecting right now is more or less than 7?
More.
More. Ani say more. Yang lain agree? Anybody disagree?
Agree.
Thank you, Go. Anybody answer?
Miss, saya dapat 8.7269.
No. 8 poin lebih kawan. Yes, lagi?
Miss, saya dapat
9.7837.
9.784.
Yes. Yes.
9.7837.
9.7837. That is the correct one. First and foremost, just very quickly we go through this sebab soalan ni adalah something yang kita dah banyak bincang last week. Okay? So over here, benda pertama kamu akan perasan we have the presence of 0.5 molar of N2H4. So in the other words, in my beaker right now, I'm placing in 0.5 molar of N2H4. And then in the same beaker, I place in 10 gram of my N2H4Cl. From there, you realize that the volume solution indirectly a liter of solution. So volume of solution right now is 1 liter volume total. Okay. So the very first thing like we discussed very quickly last week adalah what type of buffer is the first thing. That is my weak base. Automatically, that is my conjugate acid. Automatically, that will give rise to my basic buffer where Ani kata tadi the pH calculated must be more than 7. Agree? And since it's a basic buffer, ladies and gentlemen, formula yang kita akan guna mesti adalah pOH. First and foremost yang kamu kira adalah pOH. Log the concentration of the conjugate N2H5 positive over N2H4. That is the concentration that we need. And since we need them in concentration, guys, yang satu dah ada dah concentration, boleh guna 0.5? Boleh sebab 0.5 boleh guna sebab kita tak ada volume changes kat situ. Kita assume 0.5 adalah dalam 1 liter. Over here, 10 gram kena kira. So, very, very quickly, molar mass. Molar mass of N2H4Cl, kalau tak silap saya, 67.5 gram per mole. Saya perlu tunjuk ke yang ni? Kalau saya still perlu tunjuk molar mass, I'll be very sad, guys. Very, very sad. I might be crying right now. Okay, if you tell me I don't know how to calculate. If you don't know how to calculate, don't tell me. It's either I kill you, then I kill myself, or it's either I kill you and then I live happily ever after. I won't kill you guys. I love you guys so much. I don't really love you so much, but I do lah at some point. I still care about you. Okay. So concentration 0.1481 mole adalah bahagi dengan 1 liter if you realize. Because in the very first sentence, the very first word, volume of solution is 1 liter. So kamu dapat balik molar adalah pacik ni. Okay, until here, are we still together?
Yeah.
Ada soalan setakat ni? Yes, Isma say yes. Okay. So if you are okay, then we move on. Formula dah ada sayang. pOH dah ada yang kita akan cari. PKB negative log 1.8 times 10 to the power of negative 5 tambah dengan log concentration of my conjugate acid 0.1481 over 0.5. Sayang, satu je isu dunia. Tahu isu dunia dah buat? Tekan calculator betul-betul. Right? Are we together? Perfect. So pH equals to 14 minus pOH. Therefore, you will have 9.7837. Anybody disagree? Happy? Not happy? Not so happy? Aku menyampah benar tengok keluar masuk, keluar masuk, keluar masuk. Apa balik rumah boleh tak? Kita buat kau. Miss Wong ni pun satu, buat kat balik rumah pun satu hal, balik college pun satu hal. Alright, question so far. No? Okay. No, next question is, I have addition. But before that, alright, before the addition, guys, just sabar sah. In my beaker right now, I have the pH calculated is equals to 9.7837. Sorry. Dan dalam beaker ni, kita dah kira tadi, yang duduk adalah 0.5 molar N2H4. Sayang, saya nak ingatkan balik satu benda. Buffer kita tak berubah. Buffer kita masih adalah orang yang sama. Alright, buffer kita masih adalah orang yang sama. Bermakna, Miss Wong still having, everybody still having the same weak base, the same concentration, and the same conjugate acid with the same pH value. Agree? Okay. And right now the addition comes in. Soalan pertama dah lain dah dengan video. Apa kelas main sama dengan video kan? So we do something different from the video, then you learn something. So the first question that I have on the screen, soalan still tanya pH of the solution when 0.03 molar of MgOH2 is added. Okay. So sekarang yang saya tambah soalan pertama untuk soalan ni. Soalan pertama is, we are adding in strong acid or strong base.
Strong base.
Thank you. Go. We are
Strong
adding
base.
strong base. Yes. Okay. We are adding in strong base. Dalam hati kamu, dalam otak kamu, dalam hati tak payah, dalam otak je. Hati tu boleh buang dalam tong sampah tak apa. Dalam otak kena ada. So dalam otak kamu sayang, bila yang kamu tambah adalah strong base, Fazlina, the pH shall drop or increase slightly. Right? Line tak okey ke? Saya tak pasti. Zawa?
Increase slightly.
Thank you. Lovely. Zawa duduk kat mana?
Dekat dalam bilik ha.
Oi, bilik Zawa line okey weh. Dia still boleh guna background. Suara dia clear, line dia clear, everything apa boleh sebu bilik dia weh. pH will increase slightly. Okay, yang perempuan je lah pergi sebu, yang lelaki duduk bilik masing-masing. Okay? Okay, Himain? Himain antara orang yang tak boleh percaya. Okay, so over here, we have calculated the, we already know what we have. We already know what we predict. So, what is this question different from our example in YouTube? Anyone?
Ratio dia 1:2.
Yes, thank you, Itin. Ratio of my strong base is not 1:1. Soalan macam ni jarang keluar. Dia jarang tapi tak bermakna dia tak boleh. Dan saya ajar sebab saya takut dia keluar lah, obviously. Kalau 1:1 ratio dia agak senang. Contoh ya, kalau KOH. Kalau Miss Wong kata 0.01 molar of KOH, that will equals to 0.01 molar of our OH minus. Betul? Dia 1:1. Tapi isu dia sekarang adalah in my MgOH2, I will produce 2 mole of my OH minus. That is the problem. Okay? So if when I have 1 mole of magnesium hydroxide, I will form 2 mole of OH minus. So right now, 0.03 molar of magnesium hydroxide will produce 0.06 molar of OH minus. And that is one of the difference. Not the one. Not one of the only one, to be honest. So the OH minus that you have in the question right now is not the same as the base, because the base is a base that produce 2 OH minus. Nampak? Okay, nampak dah trick dia? So be very careful on that. And then the rest of the question akan sambung seperti apa yang kamu belajar. So it's a base, therefore the OH minus will be completely neutralized by who? Is a base, therefore kita akan ambil conjugate acid N2H5 plus. Arrow, single-headed arrow. Mentang-mentang kamu objektif kan, so arrow pun jadi tak penting. It should be a single-headed sebab dia patut habis. Therefore, dia akan hasilkan balik your weak base N2H4 and then you will form a byproduct of water. Setuju? Okay. Make sure you do the ice table. Ice table tak payah buat lambat, tak payah buat slow, tak payah guna pembaris, buat dengan cepat je. Okay. So, your OH minus starting off initial bukan 0.03. Your OH minus starting with 0.06. Itu beza dia. Okay. And what would be the initial of the rest of the thing? Other than 0.06 untuk OH minus, your N2H5 initial 0.5, your N2H5 positive 0.1481. That is our initial. So, initial kat sini adalah yang kamu ada dalam beaker 0.1481. Pakcik kat sini 0.5, water ignore. Okay, senang. Aina, can I have the changes?
Negative 2x.
2x, negative 2x, negative
x.
negative x. Lagi?
Negative x
Lagi?
plus x plus x.
Lagi?
And I2 ignore.
Ignore. Thank you. Yang saya nak dengar tu ignore. So over here, then you can solve your ice table very quickly. 0.06 minus x, 0.1481 minus x, 0.5 plus x. Over here, ignore. Betul? Okay. Saya tahu ada banyak cara kalau kamu tengok YouTube orang lain ataupun kamu tengok nota orang lain ataupun kamu tengok buku mana-mana, dia ada banyak cara nak selesaikan dia. Sebab sayang kalau kamu perasan dia matematik je. Betul? Dia matematik je. Dan I stick with ice table. I still love ice table. Dia bukan panjang pun. Nak buat tu senang je. Tapi ice table jelas. And we've been using ice table dari topik 6. Kenapa nak buat cara lain padahal cara yang sama boleh selesaikan semua soalan. So, guna cara yang sama. Okay? So, over here, yang saya nak adalah bahagian ni. My final. Yang saya nak is the final of this and the final of this. And to find the final, I need the x. And the next question, how do I get the x? Anyone?
0.06 minus x equals to 0.
0.06 minus x equals to 0.
Thank you. All right. So, kenapa sama dengan kosong? No, y equals to 0.
Neutralize completely.
Neutralize completely means semua OH minus yang kita tambah masuk akan habis. Therefore, OH minus final mesti kosong. From that, you will then realize 0.06 minus x equals to 0. X equals to 0.06. Okay? So when you get the x equals to 0.06 already, then life will be quite simple and straightforward. Over here, 0.1481 minus 0.06, get the new concentration. 0.5 plus 0.06, congak pun boleh dapat 0.56, okay? Over here akan dapat 0.1421, betul ke? Correct. I need to count. Where's my calculator? 1 second. Betul kan? Wrong wall. Macam akan banyak ubah je. Am I adding in too much of my base? I think yes. Oh my god, I'm adding too much of the base. Okay, never mind, leave it. We'll be fine. Okay. Next, what do we do? What do? We need to find the new pH. Okay. And how do I find the new pH? We'll be using the same formula as what we have above just now. It's a basic buffer. So we will still be using our POH equals to PKB plus the log of my conjugate today, N2H5 positive, over my weak base. Oops. Okay, can you calculate the pH for me? I want to know the new pH.
Means I get pH equals to 10.0585.
Oh no, I haven't calculated. Just want to calculate. Sorry. Setting up my iPad so that you can see me. I know you miss me, don't you? Yeah, see me. Hello. I feel bad. It just, my hair's still good, right? So it's okay kan rambut saya. All right, 1 second. Go getting what just now?
10.0585.
Too big. Acid that I add, sorry, the base that I added is too strong. Sorry, it's too much, but it's fine. $10.05, yes. Okay. Go getting 10.0585. Yang lain setuju? My bad. Definitely my bad because I'm adding in my base too strong. Sorry. Okay, too much. Saya type banyak sangat. Dia patut ada satu lagi kosong ni sebenarnya. Ni patut ada satu lagi kosong. But it's fine. Alright, we're just going to learn the calculation. So the pOH that you get over here shouldn't be a problem. The pH is a 14 minus the pOH. The changes is too big. I apologize because of my question. Kamu dapat 10.05. Okay? 0585. So the changes over here, the pH is actually increased about approximately 0.2748, about lah. Okay? So for me, this increment is quite high. It shouldn't be this high. It should be roughly about 0.0 something. Oh, I dropped everything. Got sick. Sorry. Okay. 1 second. Okay. I didn't calculate nicely before I do the question, so I apologize for the changes. But happy with the question? Do you know how to calculate? Okay. I think the most important thing in this question that I want to show you, other than the calculation that you can see from the video, is this one. When you form 2 mole of OH minus, be careful with the question. Take a good look at the base and the acid that is given, whether it's forming 1 H plus or 2 H plus, 1 OH minus or 2 OH minus. Okay? Boleh? And since we're adding into the same beaker, guys, therefore we are using the same formula of the basic buffer to calculate the value. Question? No? Boleh? Moving on to the next question. Similar question. Saya nak ubah soalan ni. Tak puas hati. Alright. Can you see the similar type of question? H2SO4. Dalam video saya tak pernah guna H2SO4 because 1 mole of your H2SO4 over here will give rise to 2 mole of your H plus. So bila saya ada 0.001 molar of H2SO4, I will give rise to how many of the H plus? Okay. Can I leave it to you and answer? 5 minutes? By the way, kalau soalan ni keluar dalam finals, kamu ada 3 minit. It's the same buffer. So I hope you remember, it's the same buffer. Okay. So in the same buffer, kamu masih ada 1 liter. The pH value masih adalah the original. Over here, 9.7837 tadi. Dalam ni, siapa yang duduk? Original banyak mana? Okay. still kena tunjuk. Saya nak jawapan daripada Khadijah. Saya nak jawapan daripada Khadijah. Dah? Ada yang dah? Aina dah? Good. Keep the answer. Khadijah, are you still here with me?
That means
Sekejap. Waiting patiently. Naik atau turun by the way? Danish, naik atau turun?
Increase, Miss.
Increase.
Drop.
Drop.
Sabrina say decrease. Thank you, Sabrina. Danish tak boleh balik college. Danish balik college, dia start dia bila ada kawan tu, dia start mampu lah. Dia duduk kat rumah, dia pandai je. Okay, waiting answer from Khadijah. The new pH is how much after the addition of my strong diprotic acid. While waiting for Khadijah punya jawapan, Danish, to compensate what you have wrongly answered just now, the H plus will be neutralized by the N2H4 or will be neutralized by the N2H5 positive.
Neutralized by N2H4, Miss.
Neutralized by N2H4. Danish hang duduk dengan siapa tu? Ramai sangat kat bilik hang tu.
Saya ada dengan Muhammad Azri.
Saya kenal ke? Azri. Kamu dengan Azri.
Ya, Miss.
Okay. So initial 0.002 for the H plus over here because of the diprotic. I hope you realize that it's a diprotic right now. And then you have your N2H4 initially in the beaker already 0.5. N2H5 positive initially in the beaker already is 0.1481 molar. Because we are adding the strong acid into the buffer solution that we have from the beginning. Okay? As always, tolak X tambah X is a 1-to-1 ratio so far. So kita dapat 0.002 tolak X, 0.5 tolak X, 0.1481 tambah X. If you got until here, kalau value ni sama, you should already correct. Okay? Kalau salah tu mesti sebab calculator. Okay? So knowing that, like what Norwesh said just now at the beginning, H plus will be completely neutralized. Sebab tu, final untuk H plus, saya rasa yang lain pun jawab tadi. Final untuk H plus, final untuk OH minus mesti adalah kosong. Dari situ kita akan dapat X. Therefore, X akan bersamaan dengan 0.002 molar. Agree? Easy. You said 0.5 minus 0.002, kamu akan dapat 0.1481 plus 0.002, kamu akan dapat kat sini. Okay? So, Khatijah dah hantar jawapan dia. So, let me take a quickly, very quickly. Alright, so apa yang Khatijah kira? Khatijah dapat 0.498 kat sini jawapan dia ya. We use jawapan dia 100%. Kita tengok betul tak jawapan dia. So, over here, next, dia dapat 0.1501. Correct me if I'm wrong. Saya tak guna otak dah. I've been using my brain too long. It's a bit tired. So, I will shut it down and you use yours. Okay? POH. Saya shut down pun. Otak saya shut down still work faster than many of you over here. That's the problem. Okay? That is the problem. Jahat mulut teruk gila, Miss Wong. Bad mood pun mulut teruk. Saya tak adalah bad mood tapi saya sedih. I sedih sebab I'm going to upload a video that I don't think I'm happy with, but I'm still going to upload it. Yeah. Alright. Dengan bunyi macam-macam tadi kat luar. It's fine. 0.1501 apa yang Khatijah bagi kat saya. 0.498 dan apa yang dia kira POH yang dia dapat kat sini 8.7344. Betul ke kelas? Mana PH awet? Han tak cari pun PH, aku tak nak POH. Oh, dia cari PH. Ada orang salah buat. Khatijah dapat yang ni sebagai PH. Dia tulis kat sini PH. Dia tulis kat sini PKA. Betul ke kelas?
Salah.
Kenapa salah?
Itu nilai untuk KB.
Itu nilai untuk KB. Dan you know what Khatijah buat? Khatijah buat yang ni pula. KW equals to KA darat KB. Okay. Interesting mistake. Very interesting mistake. Okay. Sebab Khatijah dah buat benda ni, so saya nak tunjuk. Okay. What your friend sent to me just now is this. Everybody take a look. Sebab yang ni tak boleh. So bila tak boleh, saya tak nak ada orang lain buat. What Khadijah sent to me is Khadijah sending this formula, but with my conjugate acid and weak base behind. I hope you realize that in this formula, alright, in this buffer formula, benda ni kita panggil Henderson-Hasselbalch equation. In this Henderson-Hasselbalch equation, kita tak boleh tukar apa-apa formula dia kat depan. Sayang, mana logik? Benda ni adalah weak base. Kita tahu benda ni weak base, sayang. Benda ni adalah conjugate acid, betul? Kalau dia adalah weak base over here, guys, mana logik dia ada pKa? Nampak? Saya faham formula ni tak salah. Betul. It's a 1 times 10 to the power of negative 14. Betul lah Miss Wong yang ajar formula ni. Formula ni tak salah. KA yang kamu cari pun tak salah. KA yang kamu cari betul. Tapi masalah yang salah kat sini adalah kamu tak boleh masuk dalam formula ni. Sebab kat depan adalah cerita asid. Kat depan cerita asid. Tapi kat belakang cerita weak base. Logik tak? In the same formula. Alright? So, formula ni kamu tak boleh do so. This formula kamu tak boleh tukar apa-apa KA, KB value. Thank you for the mistake that your friend do. So, I'm telling you right now, tak boleh. Kalau dia adalah weak base kat depan tu mesti adalah PKB and mesti adalah POH. Faham kelas? Alright, and Allah, saya dah kira dah. Tapi dia dah hilang. So, the POH calculated. Anybody?
I got 4.221.
4.221. 3 titik perpuluhan je. Saya nak 4 titik perpuluhan
Oops.
saya.
Wait.
4.2239.
4.2239. Thank you. Saya pun dapat yang tu. And that is only the POH. Therefore, the pH value calculated over here will be the 14 minus. Saya tak payah tunjuk dah kat kamu macam mana nak dapat. You got 9.7761. Betul? And when you minus with the original pH, 9.7837, the changes that you get, the pH change as small as 0.0076. Betul? Okay? And that is what I call small changes. Okay? And the small changes obviously from the pH lama kepada pH baru, pH dia adalah drop slightly. Kenapa drop slightly? Sebab yang saya tambah adalah strong acid. Setuju? Okay, so when strong acid is added, ladies and gentlemen, in your answer, in your objective answer A, B, C, D, pH yang kamu kira mesti kena lebih rendah daripada pH original. Nampak? Okay, question. Alright, Khatijah kira balik saya nak ingatkan sekali lagi sebelum kita move on. Formula 2 ni sayang, tak boleh ubah. Formula 2 ni tak boleh ubah sebab kat belakang tu adalah benda yang kamu takkan ubah. Benda ni adalah conjugate base over weak acid. Kenapa over weak acid? Sebab pacik ni sekarang adalah formula pKa pH. So that is my weak acid. Dan kalau formula OH, dia adalah POH. Everything about base, ladies and gentlemen. Everything about base including belakang. Belakang ni weak base. Alright? Tak boleh ubah. Sayang. Apa kenal saya berapa lama dah? 4 bulan, I think. Betul? Alright? Kalau ada cara yang lagi senang, saya ajar dah. Get it? Okay? Even though I'm horrible. Sorry. Okay, even though I'm horrible and always make your life hard, and I know that. But if I have a better way, I'll show it to you. Saya tak adalah teruk sampai macam tu. Alright, if I don't have the better way and then apa ni? If I didn't show you, that means it cannot be done. Okay? So make sure do not change everything. But thank God you're doing the mistake here and not in the exam. Still something to happy about. Okay? Any question? Boleh buat? Okay. Slightly different from the video adalah we are having a acid and base that forming 2 OH minus and 2 H plus. Okay. So yang tu je lah saya nak kamu hati-hati. The next question is also very simple and straightforward. Sama, tak ada soalan yang sama dengan video. Kecuali yang ni. We have discussed this type of question last week in the class. I want the pH value. Dan saya simpan yang senang kat belakang, by the way. It's an acidic base. It's an acidic buffer. So agak senang. And I want answer from someone.
Miss nak tanya, kita tak ada KA ke?
Oh, saya duk tunggu je kamu tanya. Lamanya baru nak guna KA. Awak tak ada orang tanya. Saya duk pegang pen dah tunggu. Takut. Ada, mana boleh tak ada. Saya duk macam tak ada siapa pun tanya. Betul ke KA ni? Betul kot. Ya, it's correct. Faster, simple question. Could be faster. Safwan, Aiman semua duduk sekali ke? Safwan, Aiman duduk dengan Isma ke?
Yes. Tak. Saya duduk dengan Aiman.
Alright. Bilik kamu sangat meriah. Can I have answer since you're sitting together? Saya nak jawapan hantar kat gambar. WhatsApp, I want to see what you write.
Miss,
Yes.
saya sangkut dekat itself. Saya tak dapat equation dia.
Tak dapat equation pun boleh buat It's salts. Rasa garam dia apa?
CH3COONA.
CH3COONA. Okay. Alright. So, ya. Boleh sambung Okay. I think one of the biggest problem over here tadi, the first problem adalah I didn't give you the KA, so bila saya bagi KA selesai lah. Okay. The next thing when you read the question, you realize that we have the acidic buffer due to the presence of our weak acid, due to the presence of its salt, bermakna dia adalah conjugate base. So right now guys, in our beaker, we have the presence of 400 milliliter of 1.15 molar of my CH3COOH, and then you have your 350 milliliter of your 1.43 molar of its salts. Okay, so kat sini kita tahu dah sayang dia adalah weak acid. Kat sini kita tahu dia adalah conjugate base. Dari sini kita tahu dia adalah acidic buffer. Dan bila kita tahu dia acidic buffer, benda yang tidak akan conteng biasa sayang. pH less than 7, betul? pH less than 7, one thing, formula, another thing. pKa plus log and conjugate bahagi weight. Betul? So the problem adalah Safwan kata, saya tak tahu weight dia siapa. Dan saya guna perkataan garam. I use the word is salts. Tapi garam sebenarnya tak payah kalau kita tak guna mass. Alright? Kalau kita perlukan garam tu adalah apa when the question give you mass. Because I need to find the molar mass. Right? Is the question giving you mass right now? No. The question is not giving you mass. The question is only giving you volume and concentration. So garam dia adalah apa? Tak penting. Yang penting conjugate base dia siapa. So, tadi kawan kamu jawab is a CH3COONA. Sayang, kalau Miss Wong kata garam saya hari ni CH3COOK, salah ke? Garam juga kan? Betul? Siapa kata dia mesti Na? So kat sini the trick of the question saya lah bila saya buat soalan tu, just nak ajar benda baru adalah when the question asking for the salt is not necessary Na. Sodium kita selalu guna sebab dia yang senang yang kamu selalu jumpa. Tapi selain daripada sodium, saya boleh jadi CH3COOK. Right? Saya boleh jadi benda lain. So dia akan bergantung pada molar mass dia. Dia akan bergantung pada dia cakap garam tu adalah apa. Okay? So sekarang dia tak cakap garam tu apa. Yang penting dia adalah conjugate. Yang penting kita tahu conjugate dia adalah apa. Tak payah letak yang ni pun tak apa. Kita hanya perlu tahu garam dia exactly adalah apa when we need the molar mass. In the other words, when the mass is given. Okay? So other than that, tak apa, tak payah. Alright? So what will happen over here then will be this thing. Will be this. You need to find the new concentration. Betul? Because we have the new volume of total, kamu ada 750 milliliter. Sayang, what formula do we use to find the new concentration? Anyone?
M1V1 equals to M2V2.
Okay, now it's too fast.
M1V1 equals to M2V2.
Thank you. M1V1 equals to M2V2. Thank you. M1V1 equals to M2V2 yang di mana I always help you to set it up because I want to make your life easier. That is before you mix. That is after. In the other words, that is our buffer. Okay. So, your M1V1 untuk your, saya perlu tunjuk ke yang ni? Saya malas nak tunjuk weh. So, the new concentration of your CH3COOH at the buffer, over here, saya dapat 0.6133 molar. And over here, CH3COO minus at the buffer, saya dapat 0.6673 molar. Correct me if I'm wrong. Correct? Perfect. And then when you have the concentration already, yang ni bukan benda baru yang ni bukan benda yang kita nak belajar malam ni pun. Yang ni adalah benda yang kita dah belajar last week. Okay? So, we have the formula pH equals to negative log of the Ka 6.65 times 10 to the power of negative 7 tambah tak muat pula dah. Okay, kamu substitute in the value, kamu akan dapat lah. So, over here, kamu akan sama dengan negative log 6.65 darab 10 kuasa negatif 7 plus the log of the conjugate, which is 0.6673 in this case, yang semua mengangguk tadi, 0.6133. Dan pH saya dapat kat sini. Fazli ni? Fazli? Fatin Asuha?
Saya dapat 6.138.
6 point? Saya rasa betul lah. Mungkin mic dia stuck. Sebab saya dengar 6.138 tapi saya dapat 2138. Saya rasa yang ni ikut jawapan dia. Setuju? Yang dapat? Okay. Wait, Zamanis hang guna mobile apa weh? Zamanis, Kuma, Go, Aina, their line is super good. Ask them what they're using. Dan
Oh, tadi siang suffer tu.
okay. Alright. Their line is super good. I can see every little movement yang Go mata dia golek kat tepi tengok kat roommate dia, I still can see that. Nowash tak tahu tengok apa pun, I can still see that. Their line is super good. Okay. So I have 6.2138 over here for my pH. Agree? pH less than 7. Betul? Okay. Problem arise for the next question. Soalan yang saya semua tunggu sebab soalan dalam tutor tak boleh buat. What happened when mil is given? What happened when the volume of the strong acid or strong base is given? Okay. Alright. We are going to do it together. Alright. So, bila dia bagi volume, saya nak lukis balik apa yang saya ada asal. So, originally in my buffer, my pH calculated is 6 point something, 6.2138. And originally, my volume is a 750 milliliter. So, I have 0.6133 of my weak acid, 633 molar. Okay, I have this molar CH3COOH. And then dalam beaker yang sama, we have 0.6673 molar of my conjugate. Setuju? Yang ni yang kita ada asal weh. Alright, yang ni yang kita ada asal. So what happened guys? Into the same beaker, I add in my strong base. Kita masukkan 5 milliliter of 0.02 molar of KOH. What makes this question different from the rest? Nampak tak the changes of the volume? Okay. Dan sayang, bila ada perubahan volume, what happened to the concentration? Will it remain? No, the concentration will not remain. Betul? But the concentration won't remain. I have one question. Sebab kalau saya nak cari balik semua concentration, dia susah. So saya nak buat ice table yang lain sedikit. Saya nak buat ice table dalam number of mole. Kenapa saya buat ice table dalam number of mole? Guys, sebab yang berubah hanya concentration. Number of mole takkan ubah. So, untuk soalan ni, saya tak perlu pun, alright, saya tak perlu pun concentration baru ni, saya kena cari semua benda dalam number of mole. Saya kena cari number of mole CH3COOH, saya kena cari number of mole CH3COO minus, saya kena cari number of mole KOH. Okay? And just a kind reminder, sayang, bila saya dah tambah masuk, my new volume will be 755 milliliter. Agree over that? Okay, simpan dulu. Number volume ni simpan dulu. So the very first thing, guys, we need to find the number of mole. So finding the number of mole of KOH, formula yang sangat senang. MV over 1000. Concentration of molar 0.02, volume 5 liter. 0.025 liter given in the question, divide by 1000. Kamu akan dapat number of mole KOH. Alright? Nak cari number of mole untuk CH3COOH. Cara yang sama, kita akan still guna MV over 1000. Concentration yang kamu jumpa 0.6133 adalah concentration yang dia duduk dalam original volume. Okay, dah kira KOH? 1 second please. Dah kira KOH please. Okay, stop saat. So, saya just nak ingatkan satu benda. Bila kamu kira number of mole of your weak acid and your conjugate base, sayang 0.6133 yang saya ambil ni, concentration yang saya ambil ni, dia duduk dalam volume 750. Jangan guna volume baru. Is that clear? Okay? Jangan guna volume baru sebab yang tu bukan concentration dalam volume baru. So volume masih adalah 750 di sini. So that is the first thing yang kamu akan selalu buat salah. So divide by 1000, carilah. Okay, number of mole baru dia kat sini pun sama. Saya nak number of mole baru untuk CH3COO minus, where the concentration 0.6673, darab dengan 750. Okay, bukan 755 ya. Divide by 1000, you get the number of mole. Okay. Saya tak bagi, kira sendiri. Yang ni saya memang nak kamu tekan. Now, next. Dah? Okay. So, KOH agak senang. Soalan dah susah dah. So, saya tak bagi lapis yang teruk gila. KOH, 1 mole KOH akan hasilkan 1 mole of your OH minus. Betul? So, yang ni tak ada isu. So, kamu dapat number of mole untuk OH minus calculated sama 1 times 10 to the power of negative 4 mole. Setuju? Okay. Sayang, equation tetap sama. OH minus is a base that was still neutralized by my acid, where my acid in this case adalah my weak acid CH3COOH. Yang ni takkan ubah. Yang ni konsep buffer akan sama. Alright, this will forever remain unchanged tambah dengan water byproduct. Yang ni tak ada masalah. Sayang, problem arise. We cannot use, we can. Bukan cannot, I wouldn't use the word cannot. Siapa yang nak guna concentration ice table boleh, tapi susah. Sebab kamu kena cari balik semua concentration dulu. So, I prefer in number of mole. Okay, final. So, initial number of mole adalah yang kamu cari. 1 times 10 to the power of 94. OH akan tolak X. Pakcik ni akan jadi 1 times 10 to the power of negative 4 minus X. Where in here will be equals to 0. Okay. Next. What would be the number of mole initial untuk CH3COOH? Datang dari mana? Anyone? What would be the number of mole initial? Nabil? Mimi? Natasha? Bersangka baik. Line teruk kot. So, kita tanya yang line okay lah. Okay. Go. Where do you get the number of mole initial?
I don't know.
You don't know. The number of mole initial is the one that you calculate just now.
Okay. 0.46.
0.45998. Do not round off.
Okay.
We are talking about small changes, so do not round off. This is the number of mole initial. Yang kamu kira tadi is the number of mole initial. Put it in. Okay, the number of mole initial right now is 0.45998. Sama juga dengan number of mole initial ni adalah yang kamu kira tadi. Okay, you already know the number of mole, you can definitely get the X. Find me the new pH. Ataupun find me until the number of mole. Find me until the number of mole final. Cuba. Cari X macam biasa. Benjin sitting with Iyad, right? You say?
Iyad and Helvan.
Oh, so many of you. I want answer. Send me your answer. Your answer or Iyad answer or Aiman answer, whatever. Oh, so many together must be very smart lah. Seorang kira satu nombor je tadi. Show me your answer. Oh, Benjin finished it so fast. Correct or not? Benjin, do you want to take a quick look on your ice table?
Oh, okay.
What is the problem? You say okay, and then what is the problem?
Where?
Oh, waiting. I'm waiting. I'm not going anywhere. Where else I can go? Waiting patiently. Okay, saya salin sebiji jawapan, I think Benjin writing. Tapi yang tiga-tiga duduk dengan dia pun tulisan sama buruk. So I cannot recognize siapa dengan siapa. So sama je buruk. Muka pun sama je. Muka sama baik. Tulisan je buruk. Saya dia pun tak masuk plat aku pula dah. Jadi yang Miss Wong lah, you know, all those things. Oh, your writing is really bad by the way. 0.459. 8 dia macam apa benda tulisan buruk gila. And over here getting da-da-da-da-da. Saya malas nak salin. Dia ada yang tak tulis juga. Benjin getting the pH at the end is 6.2140. So Benjin, have you found your problem that I said?
Cannot.
Cannot identify. So, kalau siapa yang dah siap, boleh check jawapan dengan Benjin. Jawapan dia tak ada salah apa. Saya tak kira by the way, if the answer is different from yours, bagi tahu. I don't trust him either. So if the answer that you obtain is different, saya salin 100% yeah, I'm looking at my phone right now by the way. Okay, I'm really copying from him. So if you don't trust him, then let me know. Okay. What else did I miss? Okay. So this is what he sent to me dengan adalah tulisan buruk yang lain. Anybody disagree with anything? Anybody want to say anything? Or everybody agree with what he is calculating because the answer is the same as yours? Go, same answer, Norwesh. Zawa? Same. Aina?
Same answer, Miss.
Aina sama ke?
Sama cuma
Ya, Miss. Saya dapat
kau
sama
jadi
juga.
concentration.
Thank you,
Japan.
Harisha. Lovely. Thank you. Thank you so much, Harisha. Okay. Everything is correct. Okay, so ada orang dah jawab and I'm happy at least someone is actually identified that. So first and foremost, I hope you realize that bila dia ada volume given, kita ada masalah changes of volume. Bila kita ada masalah changes of volume, satu benda je takkan ubah. There will be only one thing that is not changing, the number of mole. Because concentration will change. That's why I stable saya suruh guna number of mole. And the one that you find at the end, this one is actually number of mole. And a kind reminder from me to you over here is this guy, when you have the formula of pH equals to pKa plus log is the concentration over the concentration. And thank you, Harisha. Well done. Very well done. So what is the problem right now? Benjin and Hillman and whoever that's sitting with you, Ian, what is the problem right now?
Concentration tu.
Concentration tu. Betul? This is not concentration. But, Harisha, jawapan sama tak? But, Harisha, are you still there?
Sama, Miss.
Okay.
Boleh slide tadi. Kenapa?
Okay, jawapan dia akan sama. Okay, jawapan dia tetap sama. Kalau siapa yang kira balik, kamu akan perasan jawapan sama. Kalau dalam, what do we call that? Kalau dalam subjektif dulu, final answer is correct. Benjin and the gang akan dapat markah kat jawapan akhir. Okay, tapi dia akan hilang markah kat sini. Because this is not concentration. Betul? Tapi kenapa jawapan still akan sama? Mathematics. Sebab benda yang kamu buat adalah bahagi. Kalau dua-dua sekarang bahagi dengan 0.755, yang ni pun bahagi dengan 0.755 sebab nak tukar kepada concentration, betul? Perasan nak mathematic wise they will cancel off each other. It's a ratio. Right? It's a ratio. Nampak? So, you will still get the same answer. And disebabkan tahun ni, kita buat dalam objektif. So, kalau kamu tanya saya, disebabkan jawapan dia sama kan? Kenapa nak buat one more step? Mathematic wise is still correct because the ratio, when you divide both with concentration, the same concentration, both will cancel off. And you will then get the same pH. Betul? And this calculation is long enough to take time more than 3 minutes that you have for one question. Therefore, guys, kamu boleh buat terus dan kira pH terus. Tapi satu je saya nak minta. Bila dia bagi soalan yang ada volume, guys, satu je saya minta. I stable mesti dalam number of mole. So the only thing that you need to do is not to change it. Harisha tak salah ya apa yang Harisha buat. Apa yang Harisha buat tu betul. Okay? Cuma saya boleh bagi kelonggaran kat situ untuk kamu skip the step. Sebab mathematic wise dia akan sama. Okay? Just one thing that you cannot skip. Your ice table must be in number of mole because when the volume change, the only one thing that remain the same is the number of mole. Nampak? Okay? So, yang ni je saya nak minta. And the rest will be the same. Yang lain sama. Ada number of mole, kita akan guna number of mole ni, kita akan guna number of mole ni. Masuk dalam formula yang sama, tekan kamu akan dapat pH yang sama. And if you look at the pH, because the one that I'm adding in right now is a base. When the one that you're adding in right now is the base, you can see that your pH increase slightly. Daripada 6.2138 jadi 6.2140. And the slight increase that we are talking about adalah 0.0002. And that is the slight increase that we are talking about. And that is the reason why do not round off your answer. Is that clear? Buffer is not the place that you round off your answer when the small changes that we are looking for boleh up to darab 10 kuasa negatif 3. Kalau small changes yang kita cari adalah eksponen 10 kuasa negatif 3, eksponen negatif 3, dan kamu round off answer kamu, you won't see the small changes. Okay? Dan kamu akan rasa kenapa jawapan dia sama. Alright? So do not round off. Any problem? Shikin, did I answer your question?
Yes, Miss.
Is that okay?
Yes.
Thank you. Alright. Ada soalan? Ada benda lain nak tanya? Do you need another question? Kalau tanya, do you need? We don't. We are good. We are always good. No, you are not good. See. Calculate the pH of the solution above when how many ml you want? Let's say we add in a 5 ml of 0.15 of, nak soalan susah ke nak soalan senang? Soalan ni pun dah susah lah, kita bagi yang senang je lah. Okay. Just monoprotic, hasilkan 1H+. I want the pH. Okay. Exactly similar question like just now, sayang. And do not need to calculate the number of mole initial dah, sayang. Number of mole initial tak payah kira dah. Soalan ni akan jadi jauh lagi pendek. Sebab number of mole initial kamu dah kira dah tadi. Guna balik number of mole initial tu. It's the same buffer. Okay. Kamu hanya perlu buat satu je. Number of mole of HCl. Please. TV. TV, are you there? TV, are you there? TV? Apa lagi yang saya ingat duk ramai-ramai ni? Tashini? Tashini, are you there?
Jarang-jarang aku buat left hand. Miss.
Tashini, are you alone?
Miss.
Oh, you're alone. Iman? Iman dah balik college ke?
Dah, Miss.
Iman duduk dengan siapa, Man?
Duduk dengan Ani Zati.
Saya nak jawapan? Saya nak jawapan, sayang. Last question of tonight. Last question of tonight. Kita tunggu jawapan kamu and we are done finally. Just a very quick check. Okay, a very quick check. Kita tanya. Putri, are you there? Putri Ashikin. Line college teruk sungguh ni. Sarah? Sarah? Aku macam confused. Norwich punya line okay je, go. Kipas bilik go duk pusing pun saya nampak dengan jelas. Aina boleh guna lagi backdrop yang pelik-pelik tu. And tapi yang lain aku panggil pun dia buka mic nak susah. Aku macam confused. Apa duduk kat college yang sama guys. Everybody in KMPP kepala batas. Oh, you register in the wrong college, man. I'm so confused. Okay. Waiting answer from tadi saya panggil siapa? Saya lupa dah. Waiting answer from Anis, Izzati and lupa siapa yang aku panggil tadi. God sake. Saya tak berapa betul. Ingat ke siapa yang saya panggil? Yang saya panggil tu hantar gambar. Come on, quick. Waiting. Sebab ni tak sabar nak habis ni. I assume the line is really bad. That's why I'm giving you the answer. Alright, only for tonight and because it's the last week and because saya kena jumpa balik kelas H4P3 esok pukul 8. So I want to make sure they won't see me for like a few hours, you know, saya mimpi miswang. So a quick one, then I will give you the solution. Okay, so over here like I say, number of mole dah tak perlu kira balik. Kenapa number of mole dah tak perlu kira balik? Sebab soalan B kita dah kira. So guna balik number of mole yang kamu dah kira because it's the same buffer. Okay, untuk soalan objektif, I don't think you will have this type of convenience. Sebab dalam soalan objektif, saya rasa dia akan tanya sekali je addition. Paling banyak dia akan tanya sekali je addition. So bila dia tanya sekali je addition, dan kita kira lah. Kita doakan soalan buffer dia keluar yang senang-senang je, yang macam dalam video. Okay, we pray for that. That is the easiest one lah. Okay, so over here kita akan expect the pH will drop slightly. if you have checked your answer, the pH will drop slightly because the one that we are adding in is our acid, which is a strong acid. So I'm calculating the number of mole of my strong acid over here using MB over 1000. Tulislah, sat lagi kata tak nampak pula. The concentration 0.015, the volume over here given 5 milliliter, you have 1000. So the number of mole of acid that you are added in over here is 7.5 times 10 to the power of negative 5. Betul? pH dia mesti ubah sikit gila tak kawan. Okay. And then the next thing, when you have the acid is added in, knowing that 1 mole, always check this. Tolong sayang, always do this quick check. Tak nak tulis pun tak apa, tapi check. Okay? Make sure dia orang adalah 1-to-1, baru kamu ambil number of mole dia. So you have your H plus added in right now. The H plus will obviously be neutralized by your conjugate base. CH3COO minus, check your equation. When you neutralize by the conjugate base, the one that you produce definitely is your weak acid. Your ice table, the only thing changes is your ice table right now will be in number of mole. Your concentration H plus will be 7.5 times 10 to the power of negative 5. Over here, initially 0.5005, initially of your weak acid 0.45998. I hope everybody initial is correct right now. Okay, moving to the change, you have your minus x, you have your plus x over here. You have at the end must be equals to 0, if you remember. Disebabkan akhir dia mesti sama dengan kosong, therefore x equals to 7.5 times 10 to the power of negative 5. Agree? So you have your 0.5005 minus x. Over here, 0.45998 plus x. So kita tahu x adalah banyak mana, so kita boleh kira kat sini adalah 0.5005 minus this one. Selesaikan, you have 0.500425. Okay? Setuju? Kalau salah, let me know. Saya pun tekan calculator terus je. So if it's wrong, then let me know. Okay, we can recalculate that and we can check that. Make sure your calculation is correct. Like I always tell you right now, you don't have any place, any space of error. Okay, 30 soalan, 90 minutes. Are you ready to kill that 30 question? Or the 30 question will kill you slowly in that 30 minutes. Vice versa. Okay, so you have the pH over here, negative log of the Ka given. Ka saya berapa yang hari ini? 6.65. Times 10 to the power of negative 7, if I'm not mistaken, plus the log of the concentration of my conjugate, 0.50425 over 0.460055. Okay, and when you press your calculator, you should get the value of your pH. My question, pH dapat berapa?
6.2137.
6.213.
7.
Thank you. Setuju? I'm trying to be very mean because I give a question that have a very small changes. Okay, kalau saya tak bagi soalan yang ada small changes macam ni, hampa tak kisah, hampa round off. So when I'm giving you a question that you can see the changes that you have initially adalah 6.2138. After the addition of strong acid, the changes is about 1 times 10 to the power of negative 4 over here. 0.0001. Itu perubahan dia. Okay. So the pH drops like we say, the pH will drop slightly because the one that you added is acid. When the acid or base given in milliliter with the concentration, your ice table must be in number of mole. Mathematic wise, okay, kita betul, walaupun kita guna number of mole final, mathematic wise adalah betul. Okay, tapi kalau kamu tanya saya, kimia wise, dan kamu patut kira concentration yang barulah. Tapi disebabkan objektif, we will stick with the easy way. Okay, any question? Any question? Senang? Alright, easy. Okay, a bit Tak ada apa. Just this one. Tak ada nak jawab pun. Just nak tunjuk je. Saya takut soalan keluar. Saya dah ajar dah dalam kelas. Alright. Benda yang kita dah buat tiap-tiap hari tu, tadi, semua tu, kita dah buat dah. Kalau soalan minta qualitatively on the pH changes when a small amount of strong acid is added. Okay. Untuk soalan yang sama. So, soalan yang sama tadi adalah CH3COOH dengan CH3COO- dalam beaker saya. Okay. When the question asking for qualitatively means looking at the question soalan tak bagi value. Betul? Bila soalan tak bagi value, start lah. Biasa yang kita kira tapi sekarang dia tak bagi value. Sayang, tak ada apa. Remember what we do? Small changes of strong acid. H plus added. So, bila H plus added, buat macam biasa. pH drop slightly. So, pilihlah jawapan yang ada tulis pH decrease atau drop slightly. Ni adalah teori. So, apa maksud qualitatively? Apa maksud quality? Bukan quantity. Kita tak boleh nak kira. Tak ada quantity. So, what is meant by quality adalah this equation. H plus, okay, akan neutralized by the conjugate base. Bila dia neutralized by the conjugate base, kita akan hasilkan balik the weak acid. I hope by now everybody should be extremely good in this state. Betul? So, Zawanis dah mengantuk. So, we have 1 more minute, Zawanis. I'll let you go. So, qualitatively bermakna kamu hanya perlu tahu concentration dia kat sini decrease, concentration dia kat sini increase. That is what I mean by qualitatively. No value. No value. Sorry. Ya, kita nak habis. My pen also marah, my laptop marah, semua benda nak marah kat aku. Cheese play. Where we are? Apa benda aku cerita tadi? Qualitatively. Jangan risau dengan perkataan qualitatively. Qualitatively, I mean over here means tak ada value, tak ada quantity, tapi benda yang kita dok buat. Kamu kena tahu the expectation, what happened to the concentration akan naik atau turun. Always remember, the one that we use will be decreased. The one that we produce will be increased. This is common sense, ladies and gentlemen. Okay? Alright, and the next thing adalah, and tak ada apa, tak nak bincang apa dah. The next thing is next week we will be finishing on 7.3. Okay? Cita-cita tinggi. Calculation dia tak ada apa pun. Tapi saya tak bagi contoh calculation dalam nota. Sebab hari tu patutnya ada video lah. And I know the video is not out yet. Cuba fahamkan, cuba buat. Kalau rasa tak okay, don't worry. I promise you I'll go through every one of that. Okay? So next week, get ready with your 7.3 and try to read the notes a bit. Try to know what is actually KSP. Try to know a bit about what is solubility, what is molar solubility. Okay, the rest kita akan bincang. Boleh? Okay, a lot of calculation, a lot of ice table, tapi senang ya. Question? Nope. Nope. You forever tak ada question. Tapi bila saya kata thank you class, semua orang akan buka mic dan cakap thank you Miss Fong. Time tu internet tak ada problem, mic tak ada problem, everything will be smooth. Thank you class.
Thank you, Miss.
Thank you, Miss.
Nak cakap thank you.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss. Thank you, Miss.
Thank you. Surprise me next time, wait. Surprise me next time.
Miss.
Thank Miss.
Thank you.
Last itu.